Good morning, students. So, welcome to the maths class. So, you all know that we are dealing with the chapter circles, second chapter, that's a circle. Now, okay, what we have studied many things in the previous classes. Now, we'll move on to the new topic, that is circle and quadrilateral. Circle, you know, circle, and the quadrilateral. What do you mean by quadrilateral? Figure having four sides or 4 points or four angles. So that is called quadrilateral. Mainly we can consider square, rectangle, whatever with the four sides and all. Now we can see here a circle you have here and the quadrilateral inside of that. Which means quadrilaterals, how many points are there? 1, 2, 3, 4 points are there. So these 4 points you can see it is on the circle. That points it's on the circle you can see. But if you see here, this is also quadrilateral you have here. So but here all the 3 points are there on the circle, but 1 point is outside the circle. And if you see on the next figure, you have a circle and quadrilateral. The 4 points you have, but 1 point is inside the circle. So any speciality is there for this, we are going to see now. So this one, first figure we'll take it now. All the 4 vertices are on the circle. 4 vertices of quadrilateral are on the circle. That means this, which means the opposite angles of this quadrilateral are supplementary. What do you mean by supplementary? Supplementary means when you add the opposite angles, you will get 180 degree. So keep it in mind, whenever 4 points of the quadrilateral are on the circle means opposite angles will be supplementary. So that means, for example, I can take these two angles, that is angle B plus, that is when you add angle B plus angle D is equal to 180 degree you will get here. That is for this figure. Always remember, whenever it is on the circle, all the 4 points on the circle means when you add opposite angles, this and this, you should get 180 degree. Now, we'll come back to here. If 1 point is outside the circle, what will happen? That is, you have seen in the previous one, that is a triangle. If it is on the circle, it is 90 degree. If it is outside the circle, it is less than 90. If it is inside the circle, it is more than 90. Like that we have studied. Now, this is the case of a quadrilateral now. That was a triangle. Now, what happens for this one now? If the point is outside the circle, what happens? Angles D plus angle B, what will be the answer? Whether it is equal to 180? No, it will not be equal to 180, but it will be, when you add these both, you will get less than 180. Here it will be getting as less than 180. When you add B and D, you will get less than 180. Now what about this one? Whenever the point is inside the circle, what will happen is angle D plus angle B, you will get it as more than 180. More than 180 you will get. So this is the main thing you are studying here. Here you can see one quadrilateral with the 4 angles. You can see. Now, if I say this opposite angles are supplementary, or I can say this, if I add these 2 angles and if you get 180 degree, in that case, I can say that I can draw a circle. I can draw a circle which is passing through all these 4 vertices like this. It should pass, because opposite angles, if you add and if you get 180 degree, then it must pass all a circle through all these 4 vertices. Then that type of quadrilateral is called cyclic quadrilateral. Cyclic quadrilateral. That is the main thing. What do you mean by cyclic quadrilateral? That means if a circle can pass through all the 4 vertices of a given quadrilateral, then that type of quadrilateral is called cyclic quadrilateral. Next problem, page number 59. You have the first question. Calculate the angles of the quadrilateral in the picture and also the angles between their diagonals. Which means whichever missing angles, you have to find out that. You have a quadrilateral ABCD and you have a circle. So we told that if it is touching the circle, it is called as cyclic quadrilateral. So you can see 50 degree, 30 degree, 45 degree. Some part of the angles are given here. So you have to find out these all missing angles. Now, what we can do is just take any chord here. Any chord means any one side I can take. So for example, if I take DC as one chord, DC, just concentrate here, DC I am taking as a chord. So from the chord, one angle is moving here. One angle is moving. What is that? 45 degree. from the DC chord, one angle is moving here, that is 45 degree. So that from the same chord, another angle is moving here, that we don't know. But you know now, from one angle, whatever the angles forming, whatever the angle forming, they all will be equal. From the same angle, from the same chord, one angle formed here. From the same chord, another angle formed here. That should be same, no? 45 degree. Here should be 45 degree. That you got. So same concept you can use other also. Now I can use BC as a chord. BC as a chord I can use, so that from the BC it is going one angle here, 50 degree. So from the BC another angle is going here, that is this one. So how much it will be? That will be 50 degree. So just concentrate here, here 50, here 50, here 45, here 45. Now that is over. Next, if I take this as a chord, AD as a chord, so that from the AD one angle is moving here, that is 30 degree. So same chord, another angle is forming here, this is also 30 degree. Now which is missing? This and this is missing. That if I take AB as a chord, if I take one angle forming here, don't know how much is that. From the AB another angle is forming here, don't know how much is that. So that we don't know, that we have to find out now. So for that, what we can use? We can consider any triangle here. I can consider ABC, triangle ABC. In triangle ABC, you can see ABC here, A given 50 degree, B how much? 30 plus 45, 75. So that third angle you can find out, no? Through that you can write the same angle here also. So now how to find out the missing one angle from the triangle? That is 180 minus this sum you have to add. So we'll see how much is this first. 50 plus 30 plus 45 is 75. 75. How much is that? 50 plus 75, 125. So to find out the third angle, what you have to do is 180 minus 125. You will get it as 180 minus 125. You will get it as 55 degree. 55 degree. So the third one, that is angle C. You can see angle C 55 degree. You will get here. So that now see this AB as a chord. If you take there, it formed 55. Same chord, from the same chord another angle is forming. So the same will be 55 degree. So this is the way you can find out all these missing angles. The next topic we are going to see is the two chords. Chords means the lines which we are drawing on the circle. You can see on circle you have, and I have drawn two chords, which means that two chords speciality is what? Two diameter I have drawn. Like this, you can see the diameter. Now first chord I have given the name AB, the second one CD I have given, and the center point I have given P. So any relation is there with this piece of chords and all. When I draw the two chords, you're getting four pieces like this: AP, PB, PD, CP. Like that, four pieces you're getting. Any relation can you find in that? You can find out easily because there are two diameters. Diameter means this becomes a radius, this becomes a radius, here also radius, here also radius. So four pieces are equal, no? So here it becomes equal. I can say PA is equal to PB is equal to PC is equal to PD because they are radius. So that's why we can say those pieces are equal. Now I'm going to show you the two chords which is not a diameter. Here it is diameter, but this is not a diameter, just a chord drawn AB, CD, and the intersecting point is a P. That is given. What happens here? Whether these pieces all are equal, it will not be equal. You can see, this is a small piece, this is the largest piece, this is a somewhat other kind of piece. Like that, everything will be different. But one relation you can find out here, that is the relation we are going to study from this part. Okay, so if the figure, if you have like this, it will be PA. So here we have seen every pieces are equal, but here it is not like that. PA into PB, PA into PB is equal to PC into PD. PC into PD. That is, whatever the number you have here for PA, whatever the number you have for PB, when you multiply that, the same, whatever the number you have here, multiply product. If you get the product here, whatever you get here, and if you get whatever the product here, both will be equal. That is the relation for this figure you have. What is that? PA into PB is equal to PC into PD. That is the thing. Now we'll move on to the other figure, that is you have already two chords. One is diameter, another one is not a diameter, but that chord is passing like a perpendicular line, perpendicular to the diameter. So here what happens, we have to see. Here the two are not a diameter, but here one is diameter, another one is a perpendicular chord to the diameter. Now what happens here? Same procedure I can use here. PA into PB is equal to PC into PD. Same I can use here, but here can you say what are any specialities there here? Here perpendicular means 90 degrees there, but this is a diameter. So for that it is passing perpendicularly. So I can say PC and PD will be equal, no? The equation will be PA into PB is equal to PC into PD. PC into PD only, but PC and PD will be equal. So I can say PC only, here also PC. So PC into PD, instead of that, I can say PC into PC itself. So PC into PC is what? It's PC square. So it's PC square. So this is the equation comes here, and this is the equation comes for this diagram. So whenever the diagram you have this way, you have to remember this equation. P into PB is equal to PC into PD. Whenever the diagram you have this way, one diameter and another perpendicular chord, you have to use this one. PA into PB is equal to PC square. Based on the figure, we are going to see one problem now. Just now we have seen the figure, a circle and the two chords you have. So we know that what is the equation we studied now? PA into PB is equal to PC into PD. Now the question is, A, B, C, D are the points on the circle. A, B, C, D are the points on the circle. Given PA 12 centimeter. How much? PA 12 centimeter and PB 8 centimeter. PB 8 centimeter. That is this much 8. PC 16. PC 16 and find PD. Find PD. PD is missing. So whenever you have this type of problem, what you have to do? What we know that you have to write. We know that the thing PA into PB is equal to PC into PD. If you had another diagram, that is a diameter and the perpendicular line, means that another equation you have to use. PA into PB is equal to PC square. This is here, not that one. This is another one. So we have to use this one. Now what you have to do? Whatever we know, that you have to substitute here. PA is how much? 12. PA 12 into PB. PB is how much? 8. PB is 8 is equal to PC. The PC you know? Yes, 16 into PD. Don't know. Find PD. So PD itself. Now 12 8s are how much? 8 2s are 16. 1 carries 8 plus 1 9. 96 is equal to 16 into PD. Or I can just reverse it and write PD. Just place is changing. PD into 16 is equal to 96. Now I want to find out PD now. PD is equal to, whenever PD you are finding, this whatever along with that, you have to bring that side. So into becomes division. 96 by 16. So 16 how much are 96 you have to find out. Divide and see 16 how much are 96. 16 6 are 96 you will get. So what is your PD? 6 centimeters. So here 6 centimeter you will get. That is the answer. So this type of problem may ask. So that time you have to use the equation. Then it is easy to find out all those problems.